All right, 9.3 we'll focus on specifically, this word is arithmetic sequences. Arithmetic is the type of math and operations that we do in class every day. Arithmetic is a sequence that has a common difference between consecutive terms. Common difference. We use the letter D to represent difference between consecutive terms. All right, and then we'll list a couple examples down below here. You've already worked with some in class, but this would be an example of an arithmetic sequence. 7, 10, 13, 16, 19. Should be arithmetic because our common difference is 3. Here's another example. This would be an arithmetic sequence because our common difference is negative 2/3 in between consecutive terms, and so on and so forth. You've even written rules for these arithmetic sequences, right? The one that I was showing you on the homework was using the first term, a sub n equals the first term times, plus your common difference times n minus 1. And there's actually another way to write this rule, and really they all come from your slope-intercept form that we use for a linear function or a linear equation, right? This looks identical to a sub n equals your common difference times n, and then b stands for your y-intercept, which is where x is 0, so it would be a sub 0 terms 0 in this explicit rule for our sequences. It comes from that y equals mx plus b. Okay, so we have two equations, or two rules that we can use. One that uses the first term, so you need this n minus 1, and one that uses term 0, so you just need n. Okay, but both will work. All right, let's go practice writing the explicit rule from these following arithmetic sequences. Remember, you always need two things. You either need the first term and the common difference, or you need term 0 and the common difference. I'm going to most of the time use this equation because a lot of the times the first term is given to us. Like we have here, first term is 32. Our common difference is negative 7. Our rule would be a sub n equals negative, well, we can use our first term, 32 minus 7 times n minus 1. If you want to reorder those around and have the negative 7n minus 1 plus 32, that also works. How about for number 2? For number 2, you have the 16th term of this arithmetic sequence and the common difference. So we're missing the first term, but you have an equation for the first term, and you can use this 16 and 52 to plug in to find the first term. It would look like this. A sub 16 is, so 52 equals our first term, which we're solving for, plus our difference of 5 times, well, we know what the common difference is, we know what term 52 is. It's term 16. So 16 minus 1 is 15. And then we just keep solving. 52 equals a sub 1 plus 75. Move that 75 over. We're just solving algebraically. And we got our first term of negative, negative 23 here. All right. If you want to write the rule, that would now look like this. A sub n equals the common difference of 5 times n minus 1 minus 23. Doesn't matter what comes first. If it's the common difference or the first term, does not matter. Let's try one more and then you'll finish with 4 and 5 on your own. For number 3, now you're missing both. You're missing the first term and we're missing the common difference. Okay. Well, you can treat these just like inputs and outputs, where 9 is your input, 89 is your output. Term 9 gets you 89, and term 15 gets us 137. And then you can just solve for the difference just like you guys would with slope, where we have our change in y, 137 minus 89 over 15 minus 9. This gets us 48 over 6. Great, so we know our common difference is 8. We still need to find term 1. So you can pick either one of these points. Let's just do this one with smaller numbers and plug it into our equation. 89 equals our common difference of 8 times n minus 1. N for term 89 is 9. So 9 minus 1 is 8 plus your first term. So we get 64 plus our first term equals 89. Our first term, therefore, is 15. So our rule would look like this. A sub n equals 15 plus 8 times n minus 1. Always need two things when you're writing your explicit rule, the first term and the common difference. Okay, keep in mind these are all arithmetic sequences where it's a common difference in between consecutive terms. Write the explicit rule for 4 and 5. Go ahead. For 4, the common difference was -8, and then if you just added 8 going back, or you plugged it in and solved algebraically, you would have gotten a first term of 51. So your rule was 51 minus 8 times n minus 1. And then for number 5, from -5 to -11, this was a common difference of just 6. For your first term, if you were solving algebraically, you would have had, I would just use this right here, -5 equals 6 times 5 minus 1. I'm sorry, this needs to be a -6 because we're going down. Equals a -6 times 5 minus 1, which would be 4, plus your first term, so we get -24 plus a sub 1 equals -5. Add your 24 over. You get a first term then of 19. So your equation was a sub n equals 19 minus common difference of 6 times n minus 1. Okay, could you also just add 6 going back all the way to 1? Yep, that would also work just fine. Common difference, though, is -6 because that negative is getting larger. Okay. Always need term 1 and the common difference when you're writing the explicit rule. All right. Let's shift our focus to series and partial sums. Partial sums are the sum of a specified number of terms in a sequence. Okay, and it can be written in a couple different forms. You might see it written like this, S sub n. If you see S sub 10, that means find the sum of the first 10 terms in a sequence, or S sub 80, find the sum of the first 80 terms in the sequence, or you might see it written like 3 and 4, where it's written in sigma notation, which we talked about last lesson, and we'll revisit that again down below here. Well, let's look at number 1. You're finding the sum of the first 3 terms. Awesome. We would just plug in 1, 2, and 3 into our explicit rule here. If we plug in 1, 2 times 1 is 2, plus 1 is 3, so we have 3. Then plug in 2, which gets us 4 plus 1, so 5. You know this pattern, it just increases by 2 each time. So the sum of the first 3 terms then would be 15. Great. that's nice and easy when it's a small number like 3. But what if you want to find a larger number like 20 and you need to write this all the way out? 3 plus 5 plus 7 plus 9 plus 11 plus dot, 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 all the way out to, well, 20 we could plug in, which would be 40 plus 1. So 41. Well, shoot, that's a lot of terms there. And instead, we have an equation that might be a little easier for us to use. And it looks like this. Your partial sum equation for an arithmetic series is just going to be the sum or the average of the first and last terms divided by, well, the average, first and last term divided by 2. So the average of the first and last terms. And then times the number of terms in that series. So for number 2 here, if we're using our partial sum equation for this arithmetic series, it's the sum of the first 20 terms. It equals 20 times the first term, 3, plus the last term, 41, which again came from plugging 20 in, and then all divided by 2. Great, so let's just cut the 20 in half, gets us 10. 10 times 44 gets us the sum of 440. Much easier than adding 3, 5, 7, 9, 11, all the way up to 41. All right, let's try another here on number 3. Actually, we'll let you try 3 on your own. Let's do 4. 4 is a little tricky because now we're starting with a lower limit of 4 and an upper limit of 20. That's a lot of terms, right? That's 17 terms. Instead of adding those all out, let's use our rule again. So it's the sum of 17 terms, right? N stands for the number of terms, okay? Remember, number of terms is the upper limit minus, we talked about this last lesson, upper minus lower limit plus 1. Don't forget that plus 1. So it's 17 terms for this series. 17 times. The first term would come from plugging your lower limit in. So 5 minus our 8 gets us 38. Great. Plugging in our next term, our upper limit of 20, which would be 50 minus 80. So that would be our 30, or negative 30, divided by 2. Okay. Let's go ahead and do the 15 or the 38 minus 30 first. That's going to be an easier number to cut in half, right? That just gets us 8 divided by 2. We're left with 17 times 4 for a sum of 68, all right? So again, just be careful there. Your lower limit was not 1, it was 4. So when we're finding the first term in the series, we're plugging in a 4 here. Our upper limit was 20. So when we're plugging in 20, we need to plug in 20 for your n. Oh, we need to fix something. Sorry, let's fix something really quick. Sorry about that. Really quick fix here. I don't really know why I put 80. 20 times 2 is 40, which gives us a 10 here. There we go, that looks better. Something was looking a little off. So we would have 38 minus our 10, which is 28, divided by 2, which gives us our 14 times 17 for a total of 238. There we go, much better. All right, let's have you try just number 3 on your own. Your lower limit's 1, upper limit's 7. You have your rule right here. Go ahead and try this. So this was the sum of 7 terms. There's a total of 7, so your 7 times the average of the lower limit plus the upper limit, so plugging in 1 here. 51 minus 7 is our 44, and then plugging 7 in, which would be negative 49 plus 51, so 2. It's your average. 7 times 46 divided by 2. 7 times our 23 for a sum of 161. All right, and then for our last one here, a sum of 18 terms. Well, using our formula, 18 times, you already have your first and your last here, right? 2 plus 121 divided by 2. This whole thing is divided by 2, and it might be easier to just cut the 18 in half right away. So we get 9 times 123, which gets us 1,107. Right. Okay, great. Great work there. You're going to have some on the homework where you are finding the sum of an arithmetic series, a partial sum, and it can be written in form like this or in sigma notation, but you're going to see plenty of different examples here. Make sure you always come back to this formula. Don't forget that it is the first term, but it's the lower limit. So if you're given like number 4 in sigma notation, you want to plug in a 4 there. This is your upper limit, whatever that term in your series is, right? Divided by 2 times the total number of terms. Great work. Go ahead and get started on the homework.